Hey kids, Smath here. I want to help y'all out with your finals. So I'm making a video for you. I've got a document for you. Now, this document's probably going to show up also in Canvas, but I thought some explanation might help you a little bit. So here's what I've got. I've put together all 4 labs that you're going to have to do right here. Now let's walk through each one of these. The first one is the titration lab. That one is going to be purposeful to find out the concentration of the HCl. Plain and simple, just like we did, all right? This gives you the step-by-step. Obtain a sample of that unknown. I'm probably not going to tell you how much. You can determine how much of that you need to obtain. Just remember, you want to make sure you've got enough sample to make 2 trials with this, all right? Make sure you measure and record the volume. Use a grad cylinder for this. Add your indicator, the phenolphthalein. That's going to be in the little dropper bottles that we've been using. All right. Record the initial volume of the titrant that's in the burette. Record that initial volume. Then start adding that titrant, the NaOH. Start adding it, start adding it, start adding it until everybody knows this one. Faint pink. I've shown you guys what faint pink, super light pink, 1 drop. Be real cautious here. Record the final volume. From that, you've got the final volume, you've got the initial volume, so you know how much NaOH you used, and you know how much HCl that you had because you controlled how much you put in here. I use 20 as just a number. You can choose whatever number you want to use. So that's titration. The next one is specific heat of a metal. All right. This one we did a couple of chapters ago with thermo. You're going to determine the specific heat, C, of that metal. All right. The metal we used last time was aluminum. It was in a little shot or a pellet form. You're going to have a little bit different form of that metal, but it probably will not be aluminum. Okay. I'm going to have a hot water bath set up for you. So make sure you mass the metal, then carefully suspend it in the hot water bath. Just have it dangling. We do not want the metal to be touching the hot plate. Okay. Allow that metal to heat up for about 10 minutes. While that's heating, obtain 2 styrofoam cups, get 100 grams of tap water in there. Then record the temperature of the water that's in the cup and record the temperature of the water in the hot water bath. That's 2 temperatures, kids. Then take your metal out, add it to the styrofoam cup, stir with the thermometer vigorously, really strong. Get that water moving around it. Record the highest temp. From that, you've got everything you need to calculate the specific heat of the metal. Those calculations are in your notes. Third lab, reactions lab. Okay, here you're going to make several different types of reactions. You're going to have to write balanced chemical equations. To do this, the procedure is very simple. Most of what we're doing is going to be either a single replacement or a double replacement. We did both of those labs, and you have handouts from both of those that are from chapter 11. Okay, to do that, I'm going to have the acetate sheet, the plastic sheet for you. Put 1 or 2 drops of solution and mix that with 1 or 2 drops of another solution, or mix that with a piece of solid metal. To prepare for this one, I would go back and look at the single replacement, the double replacement, and the types of reactions lab. You will have to write formulas for this. Therefore, I say, make sure you have the chapter 9 formula writing notes with you. Formula writing is something that we've been doing first semester and second semester, so that one just carries through. All right. 3 labs down. The final lab that I'm going to ask you all to do is the molar mass of a gas. Now, we didn't do this per se, and you're not going to have to do this. You're just going to have to analyze the data. We have done that. That is in your notes. The purpose is to use the ideal gas law to calculate the molar mass of a gas. To do that, we would obtain a disposable lighter. Right? We would mass it, put that lighter underwater, and release about 97 mils of gas into a graduated cylinder. We want less than 100 here because that gas is going to warm up and get bigger than 100. Record the exact volume, then we can release the gas. All we've done is release 97 mils. Now we're going to remass the lighter, and if we subtract the latter mass from the earlier mass, the differences in the mass is how much gas that we used. That's the mass of the gas. Then we need a temperature if we're doing ideal gas law. So that temperature is the temperature of the water in the sink that we use to collect it. The pressure will be provided, so we know that. What we've got is the pressure, the temperature of the sink, the mass of the gas, and the volume of the gas. Well, if we've got P, V, and T, we should be able to calculate moles, and from the moles, we should be able to get molar mass, considering we have mass there, and we calculated moles. There is a sample of this that's in your notes in gas laws, this exact problem. Go back. This is the same data. This is the same analysis. So there you go. Those are the 4 labs you're going to be doing for your part of the lab final. If you have any questions with those, feel free to come in and ask. But before you do, go in your notes and review what we have done with these. All right, I'm Smath, and I hope this video helps you. I look forward to seeing you guys in class.